In this video, we're discussing a conceptual question about the convergence of power series. I just thought it was a great question because it doesn't really require a lot of calculation, but it does get to the heart of whether you understand this table and this property of power series. So let's say we've got a general power series. A sub n is just a representation of all the coefficients for different values of n. These are different numbers. C is the center of the series, and then we're taking x, we're subtracting c, and then we're raising that to the nth power. So when we expand this, we have a constant times x minus c to some power, plus a constant times x minus c to a different power, and so on. And so it looks like an infinitely long polynomial, where instead of having just x to some power, we've got x minus a constant to some power. So we talked about in the last video the fact that the interval of convergence and the radius of convergence of a power series takes on one of these forms. And this question over here, which I think is such a great question, gets to the heart of whether you understand this. If you have a series and it's centered at x equals c, it's possible that the only value of x that this converges for is x equals c. So our interval of convergence is a degenerate interval. It's not much of an interval at all. It's just a single point. It's x equals c. In this case, we say the radius of convergence is 0 because we're adding and subtracting 0 from c, hence the degenerate interval. Or it's possible that your power series converges on an interval like this. It's centered at c, and then you add and subtract some finite radius of convergence. Now, it may look like this. The interval of convergence may look like this if r is a finite number, or it may look slightly different. The endpoints may or may not be included. So it's possible that neither endpoint is included, just the right endpoint is included, just the left endpoint is included, or both are included. But if r is a finite number, we get something that looks like this. So it's either converging at a point, or converging on an interval around that point, or converging on the entire real line. That's the last possibility. In that case, we write r equals infinity, even though it really bothers me to say that a variable equals infinity. But we say r equals infinity, so I'll put it in quotes. So that's just saying that I guess we sort of add and subtract infinity. That's why it bothers me. But we get the entire real line as the interval of convergence of our power series. So another way, or students say, well, isn't that all the possibilities? Weren't those the only possibilities anyway? I don't feel like this is telling me anything new. Well, this is what it's saying. It's saying it has to look like one of these, so it can't look like this. This power series can't converge on an interval over here and then skip some x values and converge on an interval over here and then an interval over here. It never does that. It either converges at a point, or converges at an interval around the point, or converges on the entire real line. It's always a single interval or a single point. It's always in one piece. So we never have a union of intervals like this. This doesn't happen with power series. So this question is getting to the heart of whether or not you understand this. I don't remember which textbook this came from, but it says, suppose we've got a series that looks like this, and we know that it converges at x equals 2. Now, if we knew the coefficients a sub n, we could find out exactly where it converges using the ratio test, as we discussed in the last video, but they're not giving us a sub n, they're just telling us it converges at x equals 2. Then the question says, does the series converge or diverge, or is it impossible to tell at these 3 x values? Well, let's see, we don't have a lot of information here, but we know it converges at 2. That's one thing that we know. And the question is, does that tell us anything about whether or not the series converges at these other values? Well, let's look at the form of the series. If I'm comparing this to this, notice I'm not subtracting anything from the x's. So c is 0. This is a power series centered at x equals 0. And we know it converges at 2. So it converges at 0, We're guaranteed that, because of this, it has to converge at the center, and it also converges at 2. So we are, at a minimum, we're in this case right here. So this tells us, this first beginning part of the problem statement tells us, this implies that this is true. We're guaranteed that the series converges on an interval that is at least 2 units wide. So we're on the interval from -2 to 2 potentially. If it converges at 2, it converges at all the numbers between 0 and 2. And because these intervals are symmetric, that tells us it converges from -2 to 2. So first question says, does the series converge, diverge, or is it impossible to tell at -1? Well, x equals -1 is only 1 unit from 0. It's less than 2 units from 0, so it does converge at -1 because this implies that the series converges here. So we'll say yes, it converges at that value. What about -2? Well, from the way I've drawn it, it looks like it doesn't converge there. But it might converge. It's possible that it converges from this endpoint to this endpoint, or -2 to 2. But there's not enough information there for us to tell. It might not. It could converge or it might not converge at -2. So we'll say it's impossible to tell for x equals -2. And then for x equals 4, students almost always tell me, it obviously diverges. It definitely diverges over here at x equals 4 because x equals 4 is not on the interval, not on the interval that I drew. I know this is not to scale, sorry guys. There's 1, 3, yeah, it's not to scale. But remember, if we're asking you whether this converges at x equals 4, and all we know for sure is that it converges between -2 and 2, and at x equals 2. So it's actually impossible to tell at x equals 4 as well. The interval of convergence might be this one. It might go from -2 to 2. It might include -2 or not. We can't tell. But that just might be some subset of the entire real line. It's also possible that this converges from -4 to 4, or it converges from -5 to 5, or it converges for the entire real line. We really don't know. All we know from what we were given is that we're guaranteed convergence there on the interval from -2 to 2. So at x equals 4, we're not guaranteed that it diverges. It's impossible to tell. I love this question. Something similar to this question might show up on a exam over this material. You want to think about it. Think very carefully about this. I love this question because it's conceptual and it gets to the heart of whether or not you understand this. These are possibilities. It either converges at the center, on an interval around the center, or the entire real line. And if I know this, I am guaranteed this part, and then the other two, like you have to think very, think about the details, think about all the possibilities, and then you can answer those two as well.